and thanks to everybody who's joined us today. It's a great honour for me to be invited as one of the keynote speakers and join you all at the EV Summit here at the University of Oxford. At least now I'll be able to boast to my kids I've been to Oxford. And I do promise not to make any jokes about the weather, but when I arrived yesterday, I couldn't believe it. It's 36 degrees back in China. So my name is Peter Matkin. I'm the chief engineer at Chery Automobile, based at our headquarters in China, and I've been at Chery for over 10 years. I've come here today from Shanghai to share with you Chery's electric vehicle battery capability, the strategy that we've deployed, the test facilities, the test processes, and our manufacturing footprint. I recognize some parts of this presentation might be a little bit technical and maybe a little bit dry, but I'm going to try and make it as interesting and as simple as possible. So first, let me give you a little bit of background about Chery, because probably most of you don't know who we are, and summarize our R&D global footprint. We started business 27 years ago. In fact, we were one of the founders of the car industry in China. And last year, we sold over 1 million cars. And this year, we have a target to sell more than 1.5 million cars. We've been the biggest exporter of Chinese vehicles for more than 10 years, focusing on South America, on Southeast Asia, and the Middle East. And now we are extending into Europe and the UK. You can see here we have 7 R&D centers throughout the world. Wuhu in Anhui province is our headquarter building, and we have other centers in China for Shanghai and Hefei. And also we have an office in Frankfurt and a facility in North America. And today we employ just over 12,000 employees, 20% of which have master's and PhD qualifications, and we're increasing our headcount on the specialist areas of software and autonomous driving. And we've been consistently in the top 100 patent filing companies in the past 10 years. So at least you know a little bit of background of who we are now. To support the rapid electric vehicle expansion in China, we've built up our battery engineering capabilities in multiple dimensions, such as material technology, battery cell chemistry, pack design, battery management systems. We've been scaling up our big data for future improvements and updates, and also our manufacturing capability. And this has allowed Chery to maximize the driving range with high-density batteries, batteries to support diverse temperature ranges of Northern and Southern Europe, fast charging capabilities to reduce range anxiety. We're exceeding global safety standards, and we're delivering cost-effective solutions for our vehicles and our customers. We have extensive traditional test facilities at our headquarters in China. We have the largest crash or safety test lab in Asia. And now we've invested in the state-of-the-art material and battery cell test and experimental facilities. This means now that we have the capability to carry out simulation analysis to reduce error states and fast-track engineering solutions for chemical analysis of battery cells, battery cell reliability, and thermal management, and many more test and development activities. This slide is really at the heart of what I want to discuss today, and it's showing our energy density in watt-hours per kilogram against time. So the bottom left-hand corner represents where we are today, and as we move to the top right corner, the roadmap indicates a progression from lower to higher densities. It sort of sounds a little bit technical, but all it means is means smaller, lower cost, less powerful batteries in the bottom left-hand corner, and higher performance, fast charging capability in the top right-hand corner. So high density just equals more performance. Don't let us engineers give you all this hocus-pocus 3-letter acronym. It's relatively simple, really. So at this lower section of the chart, you can see the lighter green bars. They're showing our lithium iron phosphate, or LFP, strategy. It prioritizes cost and effectiveness and is suitable for vehicles of ranges to 300 to 600 kilometers. The blue bars at the upper section of the chart represent nickel cobalt manganese, or NCM, strategy. This delivers higher density and improved performance and is suitable for ranges exceeding 700 kilometers. So these two different strategies are delivering solutions for lower cost, smaller vehicles up to high performance sedans and heavier SUVs, where our customers expect rapid charging technology and longer range. And you can see the planned step change improvements of 10 to 20% and then 15 to 25% in specific chemistries like high voltage, high nickel content batteries, or our ultimate goal in the very top right-hand corner is the rare metal-free batteries achieving 600 watt-hours per kilogram, or the lithium air batteries of over 500 watt-hours per kilogram. It's also an important part of the application process to engineer the correct shape of battery. Large cylindrical cells typically offer higher density and better thermal management because of their shape. The cylindrical form allows for good heat dissipation, which is crucial for high-performance applications. Production process for cylindrical cells is well established, cost-effective, benefiting from those economies of scale. But their superior performance, thermal management, and durability make them ideal for high-performance applications, such as high-power electric vehicles. However, they also have some space limitations. And for this reason, we have the square or prismatic cells, which can be used to fit more snugly within the battery pack, optimizing space utilization, easier to stack, and can be more efficiently packed, which can lead to higher density per unit volume. However, there's a challenge to cool this type of battery compared to cylindrical cells. They require a more complex manufacturing process and robust casings, which in some situations can increase the cost. But prismatic cells are best suited for applications where space constraints are the primary concern. So, in summary, the Chery roadmap for future development of battery capability of different vehicle performance and cost through high technology and cell chemistry, material selection, and the battery shape. The Chery battery pack design and test verification process delivers safety standards that far exceed the industry safety tests. Performance standards from minus 35 degrees C to plus 55 degrees C, and an additional 5 extreme temperature tests, vibration, waterproof, and other shock tests. Long life testing to maximize battery state of charge after repeat charging, which we all are aware of in our mobile phones. And we have many other requirements to deliver the best vehicle range for our customers. This slide, although it's a little busy, shows our manufacturing footprint throughout China, which is located in the close proximity to our production sites. And in order to reduce the carbon footprint, we will be extending these facilities to Europe, which, as you can imagine, represents a large capital investment. And we have purchased our first manufacturing facility in Barcelona, and we should start production later this year. And we are looking for other plants in Europe and the UK, providing local jobs and new Europe and avoiding some of the new European tariffs, which I think we're all seeing more and more now. Here are 3 of our all-new electric vehicles, which we'll be bringing to Europe and the UK. A luxury high-performance sedan on the left, a luxury SUV in the center, and a more urban boxy SUV on the right, and there'll be many more to follow. They're not only EVs, but they're packed full of high technology and advanced features. And I hope when you see these on the road, you remember a little bit about today's presentation, and maybe you can go try one. And with that, I want to thank you all for listening today. I hope you enjoy the final part of the conference, and I'll now hand you back to Jill. Thanks very much. Thank you.